Okay, thank you. Thank you all for being here. Just for those who know me and who know who I am, I used to work for Objectbay. That's the company that I founded. And Objectbay is a software development company. And what this company is doing is just delivering services to other companies and we considered ourselves being a really early adopter of Agile. So I personally started very soon, even before the Agile Manifesto. And we just rent Scrum teams to people. That's what we do. And now you read Empirics. We just decided after 14 years of operations and dual mode, because we did not only do software development, but we did also teach others how to do Agile right. And that was my part, and we decided to move the whole consulting and training business line out of Objectbay, and that is going to be Empirics, which is a company that is just 4 weeks old. Okay, so my talk today is about the Code Hoover, and I would like to thank Yves for his really great introduction to the whole topic, because he mentioned a lot of things that are really very important. And I want to take you guys even deeper into the whole code thing. So why code? When we talk about Agile software development, the code is your asset. I have been coaching so many companies where I always have seen people talking about, okay, doing Scrum meeting, Scrum Master, all these kinds of things. And in my personal view, for a very long time, the whole thing about the code itself, was not paid too much attention to. It was roughly the year 2007-8 or so when Robert C. Martin, Uncle Bob, came up with his book, Clean Code. Who knows that book? Who has read it? Okay, a couple of people? Good. Okay. Who knows Uncle Bob? Okay. So my recommendation is the second book, Clean Coder, which is more on the habits of a clean coder. So I've seen a lot of companies not paying too much attention to the code, and there's this broken window syndrome. You know, you remember the picture just Eve put up the slide on. It's exactly how the code base very often looks like when I and my team, we come to our clients and coach. So let's start with why. Okay, why clean code? Why is that necessary? So if you look at, who knows this game? Gemma? You know that one? Okay, how is that? How does that work? Have you played it with 2 people, 3 people, 4 people? Let's say a team. Everybody picks a stone. What happens? Everything breaks down as long as you keep moving, changing. Software development should not be like that, but sometimes feels like that, right? So it's just who is the poor guy who pulls the last stone out of it and the whole thing breaks, okay? So if you look at that curve over time, the cost of change. So we need to change our software. You remember, there was also a slide by Yves, the Agile Manifesto. Second page, there is the second principle. Who knows that one? No, the principles on the second page. Welcome changing requirements, even late in development. Agile processes harness change for the customer's competitive advantage. Okay? What does that mean? Welcome changing requirements, even late in development. What does that mean to you? Who is from development here? Okay. What does that mean to you guys? Tell me, even late. Yes, please. Big problem. Why? You want to change the software even late? Come on. No way. How does that feel to you? Who is for bad? Okay. Do you have an option? No option. Why? Who has ever developed a system where requirements did not change? Anybody in the room? I want to get to know this person. And you? Yeah. Your first hello world. Okay, yeah. And even that changes because you wanted to have it in a different color, right? Yeah, you're totally right. So, in a very traditional way, what you see is the cost for the change is growing constantly. Probably it's even exponential growth. Why is that? Complexity. You can see this with bugs. How long bugs that are buried into the system? How long do they live there? A very long time, right? And what happens if bugs are there and complexity is there? What happens to the developers? If I tell you, okay, you gotta change this code, you get frustrated? You probably fear changing it, right? Yeah? That's what I call fear-driven development. Fear-driven development, and that's a reality, I'm not joking around here. A reality is that developers, at a certain point in time, when too many windows are broken in the code, if you have a bad code base, developers start fearing to change the code, to touch the code base. Sometimes they say, oh, this is ugly, I don't want to touch that code. Right? Sometimes they say, I don't know what this is around. And then there is the defects in there. Okay, what happens to the defects? Defects have a social life. You agree with me? They become more and more and more. Why? Why do defects become more and more? So consider yourself being a developer. You need to change some code where a defect is in it. Okay? So you look at this code and oh my God, what is that? Damn it! You don't understand that code. What are you going to do to fix the problem at hand? Your problem. Start from scratch is a good idea. Do you really do that most of the time? Make a workaround, right? So what happens? What do you do when you make a workaround? Another piece of code that is supposed to do the same thing that the original thing is doing, you probably even go further and copy and paste some pieces of code, right? Do you do that? I am doing this. I have done that. In my early days of life. Of course. I mean, there is stress, people don't have time to do that and stuff like that. So you're trying to solve your problem at hand right now, and then you say, okay, someday I will fix that, or someday someone will fix that. When is someone? Someday? It's never. It's never going to happen, right? So how likely is it that your new piece of code has another bug? Most likely. Most likely. That's why bugs have a social life. Okay? So let's go further down the road. Okay? So you're not going from fear-driven development, you're not going to fix the code base right now. You live on with it. When you end up will be what I call hate-driven development. So what is hate-driven development? People hate the code base so much that they just put it down to some end and write some piece of code in it because they just don't care anymore. You understand what I mean? Yeah, okay, thank you for laughing. Yeah, people, and then the code base is literally dead. Okay? But the problem is, that's the asset of the company. So, whenever I talk to managers about that fact, they come out of my talk totally frustrated because they realize one thing: they have no choice. They are completely, the whole thing is completely up to the developers. So I've been doing lots of agile implementations in many companies, and one of the things that I always praise, it's a cultural thing. We need to change the culture, the way we think about software development. Okay? If you're in hate-driven development, I mean, how do you end up with? The next CEO comes and he orders a rewrite. Oh, well, that's a very good idea, right? A rewrite of the whole thing. What is a rewrite? What do? You deliver what kind of business value? The same as before, but you invest, I don't know, 10 to 20 millions dollars, euros, whatsoever, right? You invest a lot of money to get the same thing. Well, actually, do you believe with the same culture in place, will you have the same thing again? Yes, you will have the same technical debt, all these bugs in there, again the same thing. And there's hundreds of companies have died from exactly that rewrite because their customers say, I'm not paying you maintenance fees for rewriting the code, I want new features. Okay? So, there is one ultimate goal, having changeable software, and that is what Agile software development is, in my personal view, mostly all about. Okay? Being able to adopt, to really have this principle number 2, reacting to change. If there is new features that the customer wants to, if you realize halfway down the road there's a new feature that makes a total impact on your customer, on his success, then you should be able to do it in a reasonable amount of time. Okay, can you read that? A little bit, okay. I want to give you an example. For instance, what is wrong? There's a couple of people who are from software development. Don't worry, we're not going too deep into the whole thing, but I'll just give you a couple of examples. Actually, this is from one of our customers. I'm allowed to show you this, not the refactored version. It's from a large bank. And this is real production code. That is code that we found in the code base. Okay, so what is wrong with this? Any ideas? It looks like complex code, yeah? It's very complex. Do you find anything that you say, okay, oh my god, what is that? Who is a Java developer here? Okay, not too many people. Anything strange? Yeah, parameter list is a very long params in, yeah? Anything else? English German, thank you. I mean, how readable is that code? It's ugly. It's really ugly, right? You cannot read. So when we talk about clean code, don't worry, I'm going to tell you all the details. One of the things that we want to have is that if you are a developer and you want to read in one flow the code, okay? And then you see, and then you understand, the code needs to tell the story. What is happening here? So how would you feel if you, as a developer, are supposed to change that code? No feelings? Or is that the feeling? Okay, I guess that's the feeling. Okay, so there's a couple, so the naming is German, English, there's a long parameter list. This code has side effects. It is not only doing what the name says. For those of you who understand what the name is, it's English add, and Aufträge is orders, so add orders. It should be named add orders, so everybody understands. But the whole thing is really ugly with the parameters. What is coming in there? What else? There's a recursion in there. Do you see that one? So it calls itself with another list. So it's just a question of how long the list is that's going to be passed into that method until the function breaks. The method will break, definitely. It's just more like a question when it will break. Okay? So, what is clean code? We're talking about Uncle Bob, Robert C. Martin. He's a very famous author and also conference speaker. If you get the chance to hear him at one conference, go there. It's really amazing. The first book about this topic was Clean Code. The second one was The Clean Coder, I told you. And there's another one that's called now Clean Architecture. You find a lot of really meaningful and worth information in there. There is another book from him that's going back to 2002, I think, something like that. That's called Agile Recipes in C# or something like that, where the solid principles are explained in very, very much details. So what he is saying, essentially, if you do a code review, the code quality can be determined by the number of WTFs per minute, okay, in the in the code review. So if you have bad code, okay, you get the point. Okay? Good code is if there is just a few WTFs. Okay? Good. So what resembles clean code? I'm not going to take you through the whole story. This talk should just be motivating you to really embed this into your software development efforts, but just to give you an idea. First of all, readable code should be meaningful names. Developers typically read code 10 times more than they write code. Who's asking for optimization? 10 times more reading means optimize for reading it, not for writing it. Okay? So, this is where you can save a lot of time. Have you ever seen yourself sitting in front of a piece of code where you just stand there and 10 minutes pass by and you say, oh my god, I still don't get the code. I still don't understand what it is doing. Meaningful names is really very helpful. When we talk about methods or function, no matter what, if you do object-oriented or procedural or functional, they should be short, okay? Small, obviously telling a story. Telling first do this, then do that, then do that, then do that. And small means, somewhere is written should not have more than 4 lines or something like that. I personally call this not a good idea. Sometimes you need to write code that has 5 or 6 lines. That's okay, as long as it is readable and understandable. Okay? Do only one thing. There is this thing called command query separation. A function should only do either do something, command, or query something. Okay? And another thing that I want to talk about briefly is comments. Who is doing comments? In the code, okay? Then I don't need to talk about too much. Okay? Comments are always failure to express in code, except for a couple of things, like legal comments, like referencing things that make absolutely sense, right? But not too many comments. So if you need to comment something, then probably this is a hint to refactor the code and write it more clean, okay? So principles for writing good code are also in design. Thanks to Yves, he has already done a couple of those here. So there's this principle of least astonishment. Who knows that? Least astonishment means that methods should do what we expect from them when we read their names. Okay? So no side effects. It should do what it is supposed to do when you read add contract. Right? It should add a contract and nothing else. It should not print the contract or something like that. It should just add the contract. Okay, you get the point. Don't repeat yourself. Who knows that one? Okay, a couple of people. What is that? What does that mean? Don't repeat yourself. Nobody wants to say it. Okay. Don't repeat yourself means that you have only one concept that you build into your software should be represented only on one place in the code, not on multiple places. Because once the concept changes, you need to change it on multiple places. Okay? It's not a question of when you remember to change on another place. It's just a question of when you will forget to do that. Right? This is where bugs come into play. Okay? KISS. You know that? Who knows that one? Keep it simple, stupid. I think people know what that is all about. It's very much tied to Yagni. You ain't gonna need it. Yves told about that. So many things that I have seen in my life where developers started to work on something. Oh, I'm gonna make this more general. I'm gonna create a class for that. Okay? You ain't gonna need it. Make a class, make it more general when you need it in more general. Okay? Make it to fit. Separation of concerns. In object-oriented languages, you also have this thing called aspects. There are multiple concerns that something has. It's more like, okay, one class, one method should do one thing, And even logging is one thing, right? So don't do too many things in one class, in one method. Avoid premature optimization. Who is a C programmer in here? C language. C++? Okay. There is a very, very old but seminal book. Brian Kernighan, you know that one? The C programming language? That's the C Bible. And he said one thing in that book, and he said, hey, make it work and then make it fast. And that's about premature optimization. He said, premature optimization is the root of all evil. Most of us developers don't get it right the first time. How could you get it perfect the first time? There's no way, okay? So, but developers have this attitude of getting it perfect the first time. Okay? Make it right the first time, and then make it better. So optimize later. Favor composition over inheritance. So I'm a quite old developer, honestly. I was educated when the whole object-oriented thing just started to fly, and inheritance was a cool new thing. Many developers are educated that inheritance is something that you use heavily. The whole community has come to the conclusion inheritance is good, but don't overuse it. Okay? It creates a lot of more complexity. Tell, don't ask. Objects should not be asked, but they should be told to do some things. So don't ask objects for their internal state. They should be asked for to do something. Okay? I see many object-oriented designs where we have a lot of a business object model where every object is pulling the inside out, right? Their internal. So information height, I'm gonna skip that a little bit. I'm gonna give you another example. So, any ideas about this one? Yeah, German, that's the same bank. they keep doing this, yeah. Parameter list also, yes. Anything else that you would say WTF, you know? For developers in here? How about nesting? Yeah, very deeply nested. Is it telling a story? So if I read that code, I was not on that team. Don't worry, I was not on that team. If I read that code, I have no clue what this is doing. How about this? That's great. This is the name. All order items of Wertpapier description are processed. I'm a fan of having good names, right? But this is the opposite case now. This guy meant it really too good. That is really interesting. This here for Java programmers, that's a no-go. And so there is that is just a good example of a loop and a conditional in a total intermix. So he didn't get it right to write a clear Boolean expression. When is it done or when is it not done? Right? And this should be in the for statement. So nobody understands. So if the item, if by link is disabled, and again, it is nonsense what he's doing. Next example here. Oh, that's cool. That's cool. Look at this here. What is that? Yeah, it's a WTF. What is he doing here? If not features, that's just the name of the team. Sprint 93. What the hell is active. So what he is doing is a feature toggle in the code. It's a no-go. Okay? And the if and the else is doing the same thing. Set other locations details now. Set other location details now. It's just we need to reformulate the conditional correct. So this is not readable code, right? So let me get just, okay, I'm already late. Solid principles, that's the part 2 of it. It's briefly, SOLI stands for single responsibility. Okay? Single responsibility means that a class should only be responsible for one thing. Just because you can should not mean you should. Okay? Make sense to you? Openclosed principle. Who knows that one? A class, a unit, should be open for extension but closed for modification. For those who are in, for the programmers here, if you have something like a comparable class interface, so you have a comparator, you have maybe a sorted list or something like that, and you can put in some integers, you can put in some floats, maybe even strings, but you can also put in a class that is not yet developed. Because you provide a comparable interface and you tell this class how to use compare. That's how you make it open for extension. But it's still not modified because the class list does not know about your class that you are going to put into the list and how to compare it, to sort it. Make sense? So if you want to extend it to the code, you don't need an open chest surgery. Barbara Liskov was one of the ladies in the field who really added a lot of value to our development community. She said a class subtypes must be suitable for their base types. Okay, in object-oriented that sounds really obvious, but that means also that the class must not make assumptions that are not explicit about the subtypes. Like this is, if it looks like a duck, quacks like a duck, but if it needs a battery, then probably it breaks. If you go to the comparable example back, if your comparable throws an exception, let's say it like that, that is a new exception, that is not a behavior that is by the contract, and then probably the class that is using it will break. Okay? So that is a kind of a contract. The interface segregation principle says, you can see very often fat interfaces, fat classes that expose a lot of interfaces. Typically, those are classes that have a lot of things that they do, and they have a group of methods that they expose to client number 1, a group of methods that they expose to client number 2. And when we talk about interface segregation, you need to change this for several reasons. Then it's probably also a violation of the single responsibility, but it could be also a violation of this interface segregation. So what is the solution to it? Make this class a little bit smaller. You can use delegation for it, okay, for those who are in software development. Dependency injection. That's a very obvious example. Yeah, nobody would solder a lamp directly to the electrical wiring. You have an interface, right? You put an interface there that's very clear. These two are for 210, 220 or 110 volts, right? And the client needs to adapt, needs to stick to the interface specification. So you're making a class that is on a lower level, not dependent. You make the higher level features not dependent on the lower level classes. Okay, like if you consider your software on layers, right? You typically have these dependencies. A dependency inversion is you create an interface on the high level, and the subclass must the lower level class must implement this interface. Very, very easy. Okay. But not very often I have seen this in good API design. So I just want to go through a couple of, okay, I'm already done. What would you say about this one? This is Ruby, this is my, actually it's not my code, I have an open source project that I run. It's Ruby code. What would you say here? How good can you read that? Is that clear? Any things that you would say that doesn't work for you? That is not fine? it's kind of a code duplication still. It's quite clean already, but it's still duplicating. Entry date is just first and last, right? That's the only difference. So maybe you can refactor that code still. There's another one that I like. So that is, you just go here. Entry is having midnight now. Midnight zone IDs. How would you like to read that one? Is more readable? Yes. Still anything that you would say that doesn't make sense? It's still a little bit too wordy, right? So you can. There is this where here. This could be extracted into a separate variable or so. Okay. What about this one? Is this method doing one thing? It's doing too many things, right? It's too much dependent on how many input parameters you give, and even the coder has put a lot of comments what you need to put in and what you can expect from the. So that is a failure to express what the method is actually doing. Okay. So, let me come to a close. Clean code is essential. So put it into the center of your teamwork. It's coding culture. We heard about the broken window syndrome. Right? I have a different explanation for that, but just to briefly say, once you allow for having dirt on the carpet in your living room, the morale is gone. Once you allow that. And it starts really with the first broken window. When the first window is broken, it's like a domino effect. The morale is gone, and you end up with fear-driven development and hate-driven development. Okay, it's not everything, but you need to also have test automation. You have test-driven development, continuous refactoring. There are a lot of things that need to go hand in hand with clean code, and also measure technical debt. Yeah. And hover the code daily. That means regular code reviews and create transparency about the code base's status. So, almost on time. Thank you. So thank you all. If there's any questions, I just want to give you the chance also come to our booth at the Coaches Clinic. I'm there most of the time, and I'm happy to talk to you. I'm happy to answer your questions. And thank you.